A shell acquires velocity v is equal to 320 meter per second, having made n, that is equal to 2 turns inside the barrel whose length is equal to L, that is equal to 2 meter. Assuming that the shell moves inside the barrel with a uniform acceleration, find the angular velocity of its axial rotation at the moment when the shell escapes the barrel. So I have drawn a figure in reference to what is given in the statement. Now this is a barrel of length L, and let us suppose this is shell. Now it will acquire some angular velocity. Let it acquires an angular velocity omega by the time it exits the barrel. Its speed is given, that is 320 meter per second, and while moving from this end of the barrel to this end, it has also completed 2 turns. So I have shown the trajectory of a point on the surface of the shell. You can take any point on the surface of the shell, and from here I have shown that it has completed 2 rotations. From here to here you can see it is 1 rotation, from here to here it is another rotation. So total 2 complete rotations this shell has made while moving from the starting point of the barrel to the end point, and I have assumed that in doing so it takes time t. Clear? So what we have to find out, we have to find out the angular velocity that it will achieve at the moment when the shell escapes the barrel. Clear? Now what we can infer from the given statement, so here it is given that a shell acquires, so we can take the initial velocity of the shell to be equal to 0 and the final velocity to be equal to 320 meter per second. Having made n is equal to 2 turns. 2 turns means, so the angle through which the shell has rotated is say theta, that is equal to 2 pi into 2, that is 4 pi radians. Clear? So this is the angle through which the shell has rotated up to the point of escape. Also it is given that we have to assume the shell moves inside the barrel with a uniform acceleration. Clear? Now this is a very important assumption in order to solve this question, as it is given that shell is rotating about its axis as well as the shell is translating. So we are assuming that the translation acceleration is constant, this is constant, and the angular acceleration, say it is alpha, it is also constant. Now we know that v square minus u square is equal to 2al, the length of the barrel, and corresponding to the rotation I can write omega square minus omega naught square is equal to 2 alpha theta. So initial speed is 0, final speed is known to us, 2a is not known to us, and L is 2 meters. Clear? And from here what we can write, omega square minus 0 2 alpha into 4 pi. So if I divide both these equations, I can write omega square by v square is equal to 8 pi alpha divided by 4a. Now I know v, but I don't know what is alpha and what is a. Now in order to calculate both these, I am using the equation v is equal to u plus at and omega is equal to omega naught plus alpha t. Now both these are 0. We know that these both are 0. So from here, if I divide both these equations, I can write alpha by a, this alpha by a, t and t gets cancelled, and that is equal to omega by v. So if I substitute here, so I will get 2 pi omega by v. So 1 omega gets cancelled, 1 v gets cancelled, and finally we will get omega equal to 2 pi into v, and v is given, v is 320 meter per second, and finally we get 640 pi radians per second. So this is our answer. There is one more way to solve this problem. Now the particle is moving from this point to this point, and it is given that the acceleration is constant. So we take the average speed of the shell as v plus u by 2, as the acceleration is constant. And also you can write that average angular speed, that is equal to omega plus omega naught by 2. Clear? Now we know that this u is 0, this omega naught is 0, and also this average speed. So what is the time taken by the shell in passing through this barrel? It is time t. So this average speed, in place of this average speed, I can write the distance traveled by the time taken in passing the barrel is equal to v by 2, and from here I can write the angle through which it has rotated. So this angle is 4 pi, clear, by t is equal to omega by 2. And if I divide both these equations, I can write omega is equal to 4 pi into v by L. Omega is equal to 4 pi v by L. And if I substitute the values of v and L, so v is 320 meter per second and this L is 2 meter. So finally I will get 640 pi radians per second. Clear? So you can use this method, second method also, to solve the problem.